Hi, everybody. My name is Kevin, and I'm going to share something with you today, something I built called SP CRUD Gen. CRUD stands for Create, Read, Update, Delete, and it does more than just those stored procedure generations for you. It creates 11 total. One of them that I'm going to show you today is the search dynamic search tool, and it's going to create 5,400 lines of code and span about 5 different tables that are linked. So what I'm going to do is first give you a little tease demo of what it does. So if you look at the screen right here behind me, you can see that it is a customer search. You've probably seen these type of things, or you've had to create these stored procedures in the background where they want to search by states and counties and organizations and payment terms and multiple different parameters. So some people call these a kitchen sink search. Some people call these a Swiss Army knife. Some call it a catch-all. Some call it a optional parameter search. So I have written a stored procedure that is going to generate this for you. If you take these parameters, you hit search, you're going to get some kind of search result. You're going to be able to sort. You're going to be able to do some type of pagination. And I will show you how the backend stored procedure can get generated without you almost writing no code at all if you don't want to. Okay, let's take a look at the table schema that we're going to be using today to demo off this SP CRUD Gen tool. So you can see that there's a customer table with pretty much the columns that you would expect to see, and this has like full amount of data in there. So it's going to link to an organization table with a foreign key. That org table is going to link to a city town. State, province, country, region table. They all link to a person table. And all of these are going to be kind of close to what you're going to find in a production system. Okay, so next thing we're going to do, we're going to want to go grab, browse out to my Kevin Martin Tech repository on GitHub. The URL's up above here, Kevin Martin Tech. Go into SP CRUD Gen. You can go, it's going to go into the main branch. You could fork this if you want, or if you want to do it a real simple, easy way, just click on SP CRUD Gen SQL, click raw, Control A, Control C or copy. Now you have the entire SP CRUD Gen stored procedure. You can see there's no stored procedures. So I'm just going to create this stored procedure, paste it, execute it. So now, if I go and refresh this, we're going to see we have one stored procedure, SP CRUD Gen. We're going to create a new, we're just going to execute it. There's a lot of parameters that you can do. You can say execute or just run as the execute. And what this is going to do is it's going to take 30 seconds and create 66. So there's 11 stored procedures, 1, 2, 3, 4, 5, 6 different tables, 1, 2, 3, 4, 5, 6 tables. This isn't like you have to run this in production. You're only going to be running this in your development environment. There's some things that could have been differently done to probably speed it up, but it's kind of looping over a lot of data set instead of doing things in batches. But if I just sit and stall for 30 seconds or so, we're going to get the stored procedures, this SP CRUD Gen to run. So it looks like I lied. It's a little over 30 seconds. Okay. So you could pass a parameter that would just generate the stored procedures. I like to do it myself. I created this little output. So it says click here to view the generated code. It gives you everything in here. So it just says copy and paste below. And then I move up here and copy, do a new query, paste. So this now is, let's see how many lines, total lines of code, of actual code we have here. So this is 48,000 lines of code that I'm going to go and just create into stored procedures here. So now if I hit refresh again, I have an entire list of stored procedures for every single one of these tables. in here, and we'll probably take a look at those in a little bit later. Okay, so even though there are 11 different stored procedures that get generated, I'm just gonna, on this video, I'm just gonna be focusing on customer search. So we can go in there and modify the stored procedure. So what I'm gonna do first before I walk through and show you what just got generated, what 5,500 lines of code just got generated for you that you did not have to type at all. Let's go ahead and start the mock the mock website that I made for this. It's super basic. I used to be a software programmer many years ago, but I'm kind of reformed. Got into databases, love databases more than programming. So this is just a little mock demo that I created. I got visit the customer search demo. So this is just a mock-up, and it executes the stored procedure, but it's not passing in any of these parameters. But I'll show you how somebody with more time and doing this professionally could wire this all together. So this is a typical kitchen sink search. Other people call it like a Swiss Army knife, a catch-all query search parameter, or optional parameter search, because you don't have to fill all of this stuff in. So a lot of times, the alternatives to this is make customer search by organization name, customer search by credit limit, organization or customer search by account open date. You could create multiple different interfaces, or create, this kind of kitchen sink functionality. And there's multiple different ways that you can handle building these type of optional kitchen sink type of stored procedures. I'll talk about a couple of the other ways, but one of the ways that I like to do, especially since I built a tool that generates it all pretty much for me, is to use dynamic SQL. So here you could search for like an organization ID 1000 where it equals, and there's a lot of different operators here. So pretty much all the operators that SQL lets you do, I have built in here. So you can say, where the organization ID equals this, does not equal it, greater than or equal to, less than or equal to, begins with, ends with, contains, does not contain, between and not between. There's also another little checkbox that says, with blank. So if you want to have, the with blanks is good if you have something like this where it's like 0 equals 0 for credit limit, or blank, right? So that's going to return you back everybody who has a credit limit of 0 or null, blank. It's called that. A lot of people and business users might not know what nulls is. You can call it whatever you want, or whatever is going to work with your customers that use your application. So another thing that this lets you do too is between. So I have seen a lot of people be able to do some really great interfaces. This is as basic as it can be for like drop down boxes and twos and between. So you could pick a from date, to date, and use between or not between. And that allows you to do kind of a range of different type of things. So all of these, you could do that too. You can do the between up here and say, I want everybody from 0 to 10,000 credit limit, and bring back the data that way. So this just gives a lot of flexibility to people who are trying to do kind of transactional, operational type of reports, to be able to bring back records so that they can do stuff with it. You can do things like multiple selects. So if you want to select a couple of these, you hold down the control in Windows. I think it's a command key in a Macintosh. And you have exists or not exists. So you could say, I want everybody where the account open date is between this range, and it exists or does not exist. Just like you can say, I only want to see people who have 30, 60, 90 days payment days on checkboxes. So this at time zone is something like, let me find Central America. So that's the time zone I'm in right now. This does, if you pass in a time or date even, right? Because if you're towards the end of like a day in another time zone, or if it was UTC, or like, a day or so away, 24-hour difference, you want to say, when I'm saying 9:30, I'm saying 9:30 Central American time, not like UTC time. So this parameter that gets passed in does two different things. One is it's passing in the time that I want my parameters here to be, and it also, if there is time zones with time zone, if there is dates with time zone offset, it's going to do a conversion to show you like what that date and time that record got saved in your time zone or whatever time zone you want to do. So when people come, they fill this out. Usually this is pages, there's tabs, there's, a lot of different stuff you can do. With that, you'd go and click search, and then you get your results, right? A lot of times the results, they can be just a huge dump, which is really ugly because it's like, what are you going to do with, 10,000 records? Here you can click on page 10, pagination. You might have next buttons. There's a lot of web interface tools that you can use that a web app UX designer can do that could really spiff this up and make this look really nice and polished. You might want to sort by customer name, payment date, ascending, descending. You might have little arrows showing up and down. So the point of this wasn't to show you like how to build, a web interface properly, but to show you like how this can execute and what like a web interface would look like based on these different parameters that you can pass in. So let's go ahead and execute that stored procedure that we were taking a look at. So this isn't the same exact values, but it's just a sample of something that you can pass in. So for each of these fields, you'll see that there are two parameters. One is going to be the value, and one is going to be the operator. So the value is going to be, whatever you have, 1,000, 2,000, greater than, equal to, less than, those drop down operators that you saw. Between is going to look like this with two. Inside SP CRUD Gen, if you use something like hyphens or dashes, you would please feel free to just go in and make a change to SP CRUD Gen to be whatever you guys want for kind of delimiting those two different ranges. It's open source, and you guys can take it and download it and do with it what you want. Pass in between. All of the stored procedures are nvarchar, so you got to pass in the n on there in order to I'll show you when we get to the code. It's nvarchar max. When you're concatenating, adding strings together, you have to keep like that same large type, so it just worked out better to do it that way. So one of the other ways is you can pass in like a JSON document / string as a value, and then that is the exist. So for the those checkboxes or the that box where you can select multiple, you can take an array inside most programming languages and serialize that to a string, and you can go to JSON, and then you're going to get this, and you're just going to have to stuff that into this parameter value. And this is working out better for me than using what are they called? User-defined tables. This JSON is way slicker. And then debug is 0. So this is the results that get sent in. You'll see there's only 100 rows because it's defaulted to 100. If you scroll all the way over, you can see a total of 355 rows got returned, but it's set up to paginate. So if we want to take a look at the SQL that it's actually dynamically running, we have that same debug. Click here to view the generated code. We can just cut this out just so we get some formatting on here. That looks nice and pretty. So with dynamic SQL, it's always pretty important that you have some type of comment string in here with a block comment instead of the inline comments. Reason being is when you come back in to performance tune, or you hire somebody like me to do performance tuning, it's really super helpful to get a comment of where this dynamic SQL actually came from, because it can come from an application, it can come from code or C# or whatever, it can come from stored procedures. So this is a kind of best practice I always tell people to do, and it's very helpful later on. Okay, so so the way this stored procedure works is breaking up queries that are very large. Instead of having one massive select statement that has, here's my select and here's all the columns that I want to return, like that's going to confuse SQL Server, and it's not going to be able to give you the most optimized query plan. So what you want to do is you want to break it up either with CTE tables like this or temp tables, to be able to just do your query stuff here and then use that with CTE or that temp table and join on it later on. And you're going to get way more performant execution plans than just writing this all as just one big query. So you could do all of these where clauses down here, all these joins down there, but it just works so much better, and you have much more performant stored procedures and queries when you break it up. So the first one is just called keys. And the reason why is because we're just coming and looking for whatever the primary key is on that table. We got the order by defaults to the key. You can pass that in with that sort order, where you can say sort by this or sort by that. And then it's going to take all of these columns. So you can see we're on the customer search, right? So that's going to be our main table that we're looking for. So what you can do, you can notice that if you do, and this is because Pascal case, uppercase, lower, 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 uppercase, lower, 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 is my preferred way. And at the company I work for, that is our format that we use for standard SQL formatting. And with that allows SP CrudGen to be able to go grab and add logical aliases. City town is just CT, state province is SP. So if you end up having something else that has Stewart Provincial or something, it's going to be SP, and then it's going to be SP1, SP2, SP3. So it is smart enough to build some logical aliases into it for you if you use this this naming schema of Pascal case. If you want to do underscores, if you want to do lowercase, if you want to do whatever you want to do, you can grab SP CrudGen source code and go in and fix and change that part of it so it's your naming schema that you use at your company. Or if your software developers are using a certain kind and you want to provide this for them, feel free to go ahead and make that change. But this is just the formatting that we use at my company. You can see here there's comments. So this is the MS description, that metadata that you can put on tables and columns. So if you go and do that, it's gonna go ahead and grab those and throw them in here too, which is going to be helpful. So I just put a couple of them in here so you can kind of see, it doesn't nothing on customer, but there's the city town has, this is city town, that's part of any address. So that's something that's kind of beneficial, that it's going to kind of self-document this for you also. So this is like the meat and potatoes is right here of like what this stored procedure does. This one equals one, that's always going to evaluate true. And then all the rest of this gets dynamically generated. And it's just an easier way to build dynamic SQL. Most people do it that way. So this is generated where you can see that credit limit is greater than the credit limit begin. And we'll get into what these parameters are when I dig into the code. You can see how it does and exists. So there's where that exists and not exists. It is going to do a select all from this payment days value, or payment days equals, or it joins on that table. That's where we take that JSON string and dump it into a temp table and be able to utilize it that way. If you don't, you're not going to be able to get good estimates. So that is done with best practices there. You can also see that this date. So when you do any dates, what a lot of people tend to do and they don't know is they screw up their sargability and they handicap their SQL Server from being able to be able to use statistics and figure it out. So if you were to wrap like something around here, like days greater than or less than or date at or something, all of the date functions and all these things, it's all going to be sargable. So it's all built with best practices to cast on this side as something so that it equals this of what gets passed in. So you can see here that it's not using like a between command operation. It's using a greater than and then less than. So greater than or equal to or less than. And it's doing like a date add to back it off. It's converting it to the proper date time to 7. It's doing that at time zone conversion because it noticed that this being passed in is a date time offset. So it's going to do this conversion for you of like what time zone that you're looking at. So the date math, I hate date math. It's hard. It took me so long. It probably took me a week just to sort out how to do a lot of the date maths and make it as performant as possible. So another small little one is the counts. That's going to get you the total over here because a lot of times you want to see, out of a total record, like you might have 350 records found. So that you can just grab the top one of the first row and use that as like something to display on the screen, you meaning the software developer or web designer. So in order to get that, this was kind of crazy. I thought I could do just a regular count like on here and like it would be fine, but that added like 2 seconds to this query where the way I found fastest for it to do is just to do another CTE table and do it here and then select out of the keys table and then cross join on count. So this adds like, so I thought this was really going to mess me up because it just kept adding like 2 or 3 seconds to even the most basic sub-second query. So this is the fastest way I found in order to do a roll total of everything, is just to follow the same rules, right? Another kind of table that it kind of gets dumped into our CTE. Okay, so down here is where we're going to select out of our 2 CTEs above. And you can see that it's all like fully aliased. It's using that at time zone from like what you passed in. So it knows that this account open date is a date time offset data type. So it knows, hey, I want to see that at the time zone that I passed in, which for me, I selected Central. This also is the format in which we use. I've seen some things where people are saying, you shouldn't do it this way. You should use as. But this way is the way that I prefer doing it. If you would like it the other way, you could go and take these and switch them around in SP CRUD Gen and do as on the right-hand side of it. So you can see all of them have the same at time zone for any of these date times. We're also following through and providing the MS description from that metadata that's there for any column. So you can see when a column has that data, it's showing it right inside there. And then here's your row total, counts equals row total. So here we're going to select from the keys table. We're joining on all of these primary keys and foreign keys to link back to all the other tables. It's also showing, descriptions if you have them. and then doing a cross join just so it throws that count rows total in every single row. So here is, now we don't have to do much of anything, right? Because we already did all the queries up above, the where clauses, the conditions up above. So now we just need to know what page we're on and how many pages that we're going to be returning. And we already did the order by up in the windowing function up above. So we just need to order by row number. So scrolling up here, we already have the order by, we already put them in the order. We already have all the where clauses here. So really all we're doing is just joining on this keys table to go and get all of this data. So I'm going to show you at the end of this also, like you might not need to return, like maybe you just want, you know, just data back from just the customer table. Or what I'm going to show you later is, hey, let's just yank off country region. We're never going to bring that back. It's always United States or something. So I'm going to show you how you can tweak this code after it's generated and save it and get rid of these columns and tables, because the less that you're going to have to bring back, the faster your queries are going to be, the less rows that it's going to bring back, the less memory the execution plan is going to have to figure out. Like, if you don't need accounting comments and this is a varchar, 4000 or something, if you yank this, it's your query is going to use that much less memory. It's going to use like half, I think, is what it ends up using. So if you just don't want any of these, we can get rid of them, and I'll show you how to do that. Let's switch back to the stored procedure, the customer search, and walk through that. So this is what got generated. This, you can see the top part of it here says auto-generated. This stored procedure was generated from a stored procedure named SPCrudGen. Notes, you can remove this comment section to keep the stored procedure from being overwritten. You should remove, select, update columns from joins that are not needed. So if you have it set up where it's going to auto-generate and just delete a stored procedure and then overwrite that stored procedure, if you want to keep that one, you just get rid of that and execute it again, because this SPCrudGen is looking for this tag right there. If it finds this tag, it knows to generate that stored procedure for you again. You haven't customized it, you haven't tweaked it, you haven't done anything. And that, if you want to leave it that way, that's good, because if you want to come and add columns or something to any of your tables, it will do it and auto-generate it for you. But once you're probably locked down with your schema and you know it's good, you could yank this and then go make tweaks to the stored procedure, and it's not going to overwrite that stored procedure for you. Okay, so let's go and look down in here on information. So this stored procedure is used to execute. It is performant, optional parameter search, kitchen sink, Swiss Army knife, catch all, and it throws in, it says on the sales.customer table. So SQL Server is going to create one cached plan for like a static catch-all stored procedure, like no matter what parameters are passed in. So the reason that you want to do like some dynamic SQL is that the dynamic SQL is going to allow you to be able to do multiple cached plans based on the different parameter or different like multiple parameter combinations that are going to get passed in. So if you want to search for just customer name, you're going to get one cached stored procedure with that parameter that gets passed in for customer name. But if you want to do customer name and like creation date, that's going to create another one. That's going to create another cache plan. And there's benefits to doing that because it's just kind of lowering the blast radius of potential like parameter sniffing, of like getting a decent plan for a smaller subset of combination of parameters. So you can use option recompile. So So option recompile is another option that you can have. You can have that one big stored procedure with or is null for each of the different where clauses. So that's another way of doing it, right? Is if you have your big, massive stored procedure with your select, and then you have all your tables and your where clause, and then you can say where company name equals the company name parameter. And then normally what people to do is say, or company name is null. So that's another way that people do a kind of kitchen sink search. But if you say option recompile on that, it's not going to save any execution plan, and every single time that you run it, it's going to recompile that stored procedure for you. But it's not always, like I say, an easy button or cheat code solution in every situation. So each time that a query is compiled, it's going to hit CPU, and that might be fine if your CPU is sitting around doing nothing. It's a small app, small queries, not a big deal. But if you're looking to build something at scale, and this might be part of code that you like install at a client site, and you don't know if they're maxing out their CPU, if they're like a at scale client where they have tons and tons of queries going on, like you should be trying to minimize the amount of the CPU compiling in those instances. So that's when you probably want to do something like this dynamic SQL. But otherwise, try option recompile if you know your environment, and you got a SQL server just sitting around bored. But hey, maybe business is going to take off, or hey, maybe we're pre-launch or something like that, and then now it gets busy, and now you have to operate at scale. You're going to be kind of sorry that you didn't build something like this to work at scale versus, hey, it works right now, I'll deal with that, that's a tomorrow's problem. If you also use this option recompile hint, you or the query performance tuner are not going to be able to view metrics tracked in the DMV. So you won't be able to see, like, hey, there's some missing indexes, what is getting executed. You're not going to get that when you're using this option recompile hint. So you're kind of handicapping yourself or somebody like me who comes in later to try tuning queries or tuning indexes. That's going to be really tough to do. One thing is there's queries. Panel.v's got one where you can go and look to see if the plan cache is 20 to 30% is like ad hoc queries in there. So if you get to 20-30%, you're probably going to want to enable the optimize for ad hoc workloads. So that's going to be a best practice I recommend. So this dynamic SQL store procedure does not prevent parameter sniffing. So one thing that you can do is you can use this code, but what you want to do is you want to do a comment injection. So because every time that you change any of the text of the dynamic SQL or any SQL, if you have even a space in there, it's going to say, "Ooh, I need to create a new plan." So what you want to do is if you have like a query that has like a big data distribution, there's big data, medium data. If you know a specific parameter value is going to return a large amount of data, like if you have like a product 4 or something like that, then you want to add, right here, customer type 1. If you know that that's going to bring back like a lot of data, you can add some kind of comment in there of just customer type 1. It needs a different cached execution plan, customer type 3. So that way, when that parameter and that value get passed inside your dynamic SQL, it's going to get this tag or the next tag with a 2 or 3. And if it's a medium plan or a big plan, it's going to figure out how to allocate enough resources properly, and it's going to give you a better plan to do that. So there's a lot of different ways to handle parameter sniffing. If you go and query for Erlen Sommerskog, Sommerskog, slow in the application, fast in SSMS, you're going to find like pages and pages of figuring out how to deal with parameter sniffing. So this isn't here to solve it. If you want to, I would do common injections in this dynamic SQL that could help you out if that's a problem that you're having. So another solution, branching. So I've done that before. You can have like a main stored procedure, and then that can sub out to sub-stored procedures. That's another way to combat parameter sniffing issues. I've done that before. So okay, so the next thing to talk about here are parameters. So there are 3 ways to pass parameters for each column. There are samples below with their supported operators. So you can see it's going to be parameter, column name, value. We saw that before. Is one of the things, and then there's column name operator that gets passed in. So if you're just passing in a single value, it's going to be equals value. So for the single value, these are the allowed operators that can get passed in. So equals with blanks. So not every type has a way to do it. So like between is only ranged value. So you can see ranged value operators allowed are just these few here. So for ranged values, you're still going to pass in value, but you're going to say value1 space TO space again value2. And then you could go and edit this inside the original SPCRUD if you use hyphens, whatever you want to do, right? We use 2. I built this for using 2 because you can throw that in there, and there's interfaces that just have that as part of the drop down. So if you have date, 1/1 to 1/30, like it's just a good human English way to have it in the interface, and it just makes the most amount of sense for the things that I see. So multi-value JSON you can pass in. So this is, if you were to just take an array, a single valued array, and just serialize that, you're going to get text like this inside your code, and it uses exists and not exists. So there's ways in which you can kind of take a peek, a look at to go see how to serialize JSON. I've done this other ways before in history where you do like user-defined tables, and then you can use what do you use? You use something inside code, and then you just attach that to the parameter, and it does that for you. But this is kind of more of a straightforward way of doing that, and then you don't have to mess with creating anything in the back end. You don't have to know anything about how to create user-defined tables. Okay, so operator, different column data types have different operators that apply. So there's 3 different kinds: numeric, string, and datetime column. So each of them has their own set of operators that they support. So columns, these are the data types that are supported for numeric. String columns, that's what's supported for string. Date time, this is what's supported for date time. So not every single type inside of SQL Server is supported. Some of them just did not work, but I went through all of them, and these are the ones that I could get to work. So, okay, so we can talk about page number. So page number, this is for the pagination of the query results. You pass 1 to return the first page. So here's 1, first page. Pass 2 for the second page. So that's how, when you click on it, that needs to get sent back to the query in order to grab the second page. So page size, this is for the pagination results. So pass 100 to return the first 100, or 10 or 20 for each page number. If you want to, you can set this to that number there. It's the highest number that you could do, I think, for an int or whatever I'm using. Keep page number to 1, and you're going to return all the rows, or up to that amount. I mean, you could have more than that, but if you're doing this type of queries and searches for interfaces, um, you know, if you need to really export all of your non-paginated data, you probably are using the wrong tool for this. That might be like, use SSIS or dump it or something like that. That's more custom made. So order column, this is for the sort order. So if you come here and click ascending, descending, that is what you're going to pass in is the order column. And because this can span multiple different tables in this query, you're going to need to pass in also order column alias parameter. So if this is only going to be for like one table, you could come and edit this stored procedure and hard code this if you wanted to, but otherwise it needs to know items like if we go down and you can see that there is row update, like there might be the same name of a column in multiple tables. So that's why you need to go and pass in the alias so that it knows the column of the table. It knows the column of the table. The table is the alias there. Order direction, ascending, descending. So there's the at time zone. To get a list of all the at time zones that are there, if you were to execute this code in SQL Server, it's going to give you a list of all the supported time zone names. So that is where I just built this list here is from that. Debug, that's where it's going to show you the link that you can click on and view. If you set it to 0, it's just going to exit the query. If you set it to 1, it's going to show you that little link you can click on to view the query. So MIT license, provided as is, no warranty, but you are free to use, merge, publish, distribute without limitations. Go ahead and take a peek at that if you have any confusion on like what you can actually do with this. So let's scroll down. We kind of saw all of these parameters. These are almost all tables except for like up to here. So everything above there is for every column in each of the different tables. And then these, if you want to, you can go and default this in SPCrudGen to your time zone that you want to default it to if you use it. I'm in Central Time, so I just defaulted to there. There's the query again, so you can find all the different time zones. I defaulted to page 1, page size 100. It's defaulted to the main table, C for customer. And it defaults it to ascending on the primary key and defaults to 0. Okay, so let's take a look at setting up some of these declared variables. The string to execute, that is going to be the main query that the main string that we're going to build our executable query string with. And then other separator string position is going to be used later on. Parameter definition is going to be used later on. It's weird building something because normally I would just put the equal, the setting it equal to here or setting the 0 equal to here. But for this to be supported in older versions of like before 2012, and I've ran this even back to 2000, but 2005, I would say it's supported back to. You have to declare your variable and then set it equal to something down farther. So I get it. I don't do normal things this way when I know I'm building things for certain versions of SQL Server, but this is the way I had to make it so that it's compatible with older versions of SQL Server. Okay, so here's a chunk of parameter variables. So this is used for splitting parameters into a begin and end for every single variable so that we can use begin operators if we're going to use those. So every single column has a begin and end in the data type in which it is inside the database itself. Except for dates, those had to be a little bit different. So go ahead and scroll down, and then we have another chunk of create temp tables. So this is used for inserting JSON into, so you insert, so one of the best practices is you want to insert the JSON or a comma separated or anything that you need to like parse or do anything, you should be dumping them into a temp table. Your estimates are going to work out a heck of a lot better for you. So did the same thing type of here is whatever the data set type or the data type is, it's creating a temp table. So all of this code doesn't, like, even this is huge, right? This is a very large stored procedure, but it's just meant to generate a stored procedure that's, you know, only this big versus, you know, all of this that's needed. So all of this extra stuff in here, if you don't need it, you can come in and delete it, right? So that's the whole great part of it, is it's a lot easier just to start deleting stuff than having to go in and type all of this, you know, from scratch. Okay, so we're going to check if the order column parameter is valid, and this is just a list of all the different columns that are in there. If it's something, so this is kind of prevent SQL injection. You don't want somebody to do, you know, drop Bobby tables here to be able to inject some code. So then it just raise an error that says, hey, it's not valid table column, so can't run this for you. And then this is where we're going to start building our string. First thing is, there's that little text I said that you should put in there. And then you can see the with keys portion of it. So all of this got generated for you, right? All, you know, passing in the order column, all of these different things up here, all these different parameters getting passed in. So how I built this, it was like dynamic. I had to write dynamic SQL with 8 quotes so that when it generated the quotes for the dynamic stored procedure here, there was 4 quotes, and then when it gets executed, it does 2 quotes to escape things. So I was really building dynamic SQL to build dynamic SQL that runs dynamic SQL. So it was like a really big inception issue that I had to keep thinking about as I was developing this. And the whole time I was developing it, I kept figuring, oh, tomorrow I bet you I'm going to figure out why no one has built something like this. Like, for months, I thought I was going to hit something that was going to make it be like, oh, yeah, great, I wasted a bunch of time building this. This is why you can't build something like this. And by the time I got done with it, I was absolutely amazed at, like, I never hit any of those. I thought I hit them a couple times, figured out ways to get around it and make it work, but I was just kind of astonished, and like I sat and looked at what I wrote, and I actually said, this is so confusing on how this thing is built, because I took everything in so many little chunks, right? Little pieces, and built on it, and little pieces built on it. And I'm like, I can kind of see why no one has built something like this before, because it was just so tough for me to get my head wrapped around each of these little tiny segments that I built, that I initially built and then put it all back together as one big SP CRUD gen. But it's here, it's working, and it's a gift to the SQL community. Okay, so then it goes into each of these different sections. So if you see, I can collapse each of these, and you'll notice that each of them is for all the stored procedures that can get passed in. So if we just take a peek at like payment day, or look at credit limit. So it's going to say, hey, if credit limit value is not null, or credit limit operator is in blanks or non-blanks, because remember, we want to be able to pass in, you know, nulls or not nulls. We might have a credit limit value, or we might be saying, hey, just give me all the blanks or the nulls, or not null, not blanks. So first thing we're going to do on this is figure out if the value contains this to string. And that's going to let us know. So that's going to let us know if it's like a range, or a between, right? Yeah, a range. So it's going to go and just do, hey, is this 2 in there? Set the set the starting position, the separator starting position, and then it gets used down here to figure out to separate it between the begin and end. Let's just take a look at this down here, so we don't have to go back up. So this is going to, this section down here is it's going to split the value into the begin and end variable for the other where separators, the other operators and stuff. So it's pretty much, if the starting position, if there is no separator position, 0, just set it begin and end equal to the value that got passed in. But if it does have a separator position of 2, 3, 4, 5, we do a little substring action that puts it from the beginning to the end, so it's going to separate those two. So if the credit limit operator is an exist or not exist, we're just going to extract the JSON array into the temporary table. So this is where we're doing that insert into the credit limit value, credit limit for use with the exists and not exists for the where operator. So it's just doing an open JSON, taking the value we pass in, selecting the value out of it, and then just dumping it into this temp table. So then here we start building the string that we're going to slap back into the where clause. So this is just a brute force for each single one of these: equals with blanks, does not equal with blanks, greater than. Like, there's probably more elegant ways that this could be done based on like types and stuff like that, but and really talking about the code that generates this code, like, this is pretty straightforward, and this part has to be done, but the SP CRUD code that generates this dynamic SQL, so the dynamic SQL before this dynamic SQL also does this, where it's kind of just brute force, just lays it out. But in order for me to get my head wrapped around, I needed to see it all written out just like it was like SQL as I was writing, as I would normally write like something like this. So what this does is say, hey, when this operator is equals, we're just going to do very basic equals. When it's equals with blanks, we're going to do it. When it's or, we're going to do the same equal, or is null. So all of these, this is how it all breaks down. So if you ever need to see like what it's going to do, how, what each of these operators are going to do, you can see it here and play with it. So the thing that's a little bit different is if it's exists. So when exists, it's doing exists select all from the temp table where it equals and joins onto that customer table. So and it'll just throw, when you chosen like one of the operators that doesn't exist for that, you're going to get 1 equals 2, and it's going to say operator not supported. You're not going to get any results that come back. So we'll take a look at the next section. Okay, so I scrolled down to the end. You can kind of see where I'm at with my scroll bar over here. So this entire red area here is all the dynamic where clauses. So once you get to the end of it, we're going to come down here. This is the last one. So here you'll see where it kind of then, after the where clause, it's going to do the counts, puts the count in there, and then it's going to do all your selects of your parameter, or of all your columns there. All of this was all dynamically generated in SP CRUD Gen that generated customer search, which is also dynamic SQL. Remember, we got 2 levels of like inception of dynamic SQL here. So we already kind of went through what all these guys do, what debug does. So then what we do is we're going to take this string, and if you want to debug it, this is how it's going to output that path as processing instructions output for XML path that makes it click on. Else, we're going to execute it. So I set up parameter definition. So these are all the parameters. I create a parameter definition that defines all the parameters that are going to get passed in. And then we're going to execute sp underscore execute SQL. We're going to pass in the statement, the string to execute, the parameter definition, and then the rest of this is all the parameters that we're passing in that matches that parameter definition. So the cool thing about this is if you don't use all of these, it doesn't hurt. These are optional. It's not going to slow anything down if you pass everything in and you don't use credit limit end or begin. So that's pretty cool. Let's say we want to edit this stored procedure, right? We want to make it faster. We want to clean it up. We don't need the country region table. So I'm going to walk through and show you how easier it is just to delete code that you don't need versus having to write all 5,500 rows of this. So we're going to remove the auto-generated comment. Gone. Okay. Then what we're going to do, we're going to get rid of the country region. So let's go and find the first column, country name, and search for that. All right, now that we found it. So I'm pretty much, you can see all of these here. These all match columns in the country region table. So what I'm going to do is I'm just going to yank all of these out of here because we don't want people to search by these. And you can see there's a bunch of red down here now because you don't have a parameter. It's going to be telling you that things are broken. Okay. So we're going to search for country name again. We can go find all of these are also country name. You can see the columns that are duplicates in all the tables, person ID, CR, CR, CR. So we can get rid of those. And now for the JSON tables, we can yank those too. We search for country name again. We're going to look for some of the order columns that are allowed. And we can yank off a bunch of these. Okay, so for the where clause, we can see all the angry red down here. So all of these, you can see I could collapse them all, but I'm just going to scroll all the way down until all of the country records, which happens to just be at the end. I'm going to delete those. Now I'm going to find the select columns. Going to get rid of them. Leave the rows total. Okay. Now we're going to get rid of the join to the country region table. Search again. And then this is going to be the parameter definitions. So we got from the country region name all the way down to the rest of them. And I accidentally always grab that and make my code error. So I got to make sure you're keeping that quote there. And now we're into the parameters that are passed into the execute SQL. Keep that last semicolon. Put that into production, see if it works. It worked. So let's execute the stored procedure again. And that still works. Usually miss something when I do that, but we just got rid of a bunch of queries. We could probably take a peek at the output code. Oh, we still got the country region in there. So let's go back. in the first section up here. We still had the country region here, so we can yank that out, put it back into production. And then run the code again. We can take a peek at the code. And now we don't have country region on there anymore. So it's going to be really beneficial for you to go and clean and slim a lot of this up, because it's going to make your queries more performant on if you don't need country region, you only need state province. I mean, you could get rid of all of it if you needed to, you know, if you wanted just a super slim off of one table and it had everything that somebody wanted to query on, go ahead and use just that one table. That works. If you can get away with that, that's going to make it that much quicker. Let's do some performance testing. We're going to use the person table. So in the person table, we have 10 million records. In the organization table, 656,000 records. So each person links to an organization, or multiple people belong to an organization. So I'm going to show you like how you're going to get multiple different execution plans here. So okay, let's take a look at SP Blitz Cache to see what's in the execution plan. So I've been using SP Blitz Cache and all of Brenozar's tools for a long time, for many years as a consultant, but even before that. So I highly recommend you go take a look at his scripts. They're all open source and free to use. So one of the things that we can see is, you can see procedure or function. If you copy this, paste it into a new window, format it. It's pretty big, so this is going to take a little bit of time. So this is where you got to do a little formatting of some things. Now we're going to get a nice little looking code for the query. So you already know like where it's coming from. You can see that the create procedure is the person search. It's going to format this a little bit nicer here, and I'm using Redgate's tools to do the formatting. So this is a stored procedure that's getting run. So that's what is showing here. But then each of these statements, right? If we were to take each of these statements, paste, format, copy, paste, format. So if we look at each of these, you can see these are the different searches that we did, one for organization name and one for search name. So it has two different plans for each of those, and it tells you the different cost associated with each of them. You can click on it and see the plans of like what exactly happened. And then if you keep going over, it'll tell you like what the execution parameters got cached with. So you can see these are those defaults, but then the search name of Dan for that one. And then this one was, organization name for Steve, right? So it keeps track of the executions here. And this is really just showing you that it is caching two different plans with each of the different dynamic SQL based on the different text that is getting created with the dynamic SQL. Okay, so what I just showed you today was one of the stored procedures that is generated from SP-CRUD-gen. There are 11 total. So go ahead and take a look at the Git repo. Go ahead and download it, play with it. It is going to save you a lot of time writing basic stored procedures, but it's also going to be able to give you a big jump start on creating some very difficult stored procedures like the kitchen sink stored procedure that we just looked at today. All of them have been done with all the best practices that we implement in my current company and a consulting company. They are pretty much industry best practice standards for development. And take a look at them and go check them out. Hope you enjoy. Thanks. Bye.